Good afternoon everyone. For today's video, we will going to tackle on how to solve for the first derivative of a function. I'll see you in a bit. Before tackling how to find the first derivative, let us first define what derivative means. According to QMath, derivatives are used to find the rate of changes of a quantity with respect to the other quantity. So when you are dealing with derivative, you are also finding for the instantaneous rate of change at a certain point. Remember that when you are finding for the first derivative, you can also find for the slope of the tangent line. So, what are the uses of derivatives? Derivatives has many uses in different fields. So I have here two examples of uses of derivatives. For example, when you are recording for the monthly profit, you can actually know what are the changes, or for example here in January, you can, using derivative, you can find out if your business has increasing profit or decreasing profit. And another example is that recording the COVID cases in the field of medicine. So this is actually done by WHO, the World Health Organization. So when they are recording for the COVID cases, they will know if there's an instantaneous rate of change in the COVID cases with respect to the x-axis or to the time. So here, this is the graph of the average rate of change, and finding the average rate of change. So this is the average rate of the two points creating a secant. So when finding the slope of a secant or 2 points, you will use the rise and run this is the formula for the slope of a line. So why are we talking about this? So this is basically connected on how the formula for the long method or for the first derivative is created. Yeah, like that. So here, this point is x plus h, and the y-axis is f of x plus h, and this is actually x, and this is f of x. So this is the value of x since it is a domain, and f of x is basically the y value. So here, x plus h, because it moves, or may distance sila x units up, and h units up, and h units in the right. So x plus h and f of x plus h. Parang yun yung distance nila sa in between. So to find the slope of this secant, you will use rise and run. So f of x plus h minus the f of x, so here, and run is x plus h minus x. So positive x minus x is 0, so yung matitira is h. So rise and run. Slope, rise and run. So this is the rise. So f of x plus h minus f of x divided by h. So that is for the average rate of change. So here in the second graph, this is actually the tangent line. So this secant line moves to downward, so it creates a tangent line in a certain point. So that is the instantaneous rate of change. So that is basically to find the slope of that tangent line, you will also actually use this one. But since nawala na yung h, you will use limit of f of x plus h minus f of x divided by h as x will become x approaches to 0. So that is how they find the formula on how to find the first derivative. Pero masyadong mahaba pag ginamit mo yung formula na to. So in this video, we will use the shortcut method on how to solve for the first derivative. So for example, this one, let's find the derivative of, let's remove this, mabadla. F of x is equals to 2x cubed plus 3x squared minus 36x plus 5. So I recommend you to watch watch in YouTube the rules of differentiability. Rules of differentiation. I recommend you to watch the rules of differentiation because that is how that is the way on finding the derivative in a faster way. For example, you are in exam like that, so you can use the rules of differentiation para hindi hassle or hindi maubos yung time mo for one problem. So to find the derivative of this, you will find the derivative of 2x cubed. So 3 times 2, kasi ito ililipat mo dito or ito times mo yung exponent niya sa 2, that is for constant and a variable rule, x, then this exponent you will minus 3 minus 1 plus, same as here, 2 times 3 x 2 minus 1, and here minus 36. So 1 lang naman yan, so pag i-move mo 36 times 1, 36, negative 36. Tapos x minus 1 is mawala na kasi x minus 1, it has exponent of 1 minus 1 is 0, any number raised to 0 is 1, and the derivative of 5 is 0. So 3 times 2, 6 x squared plus 6x minus 36. So that is the derivative. So this is the derivative of this function. If you want to find the second derivative, you can also you will just find the derivative of this first derivative. Okay, kiwit pala. Sorry. So, if you want to find the slope of a tangent line, you will just input the value of x here and you will just change all the values of x to the values you wanted to find out. So for example, the tangent if x is equals to 1. So 6 times 1 squared plus 6 times 1 minus 36. So 6 plus 6 minus 36. So 12 minus 36 is negative 24. Okay, so that is the slope at point 1. Since negative, I think this is downward slope. Then let's move on to another example. Here, find the derivative of f of x is equals to x squared minus 5x plus 3. So you will use the rules of differentiation to find the derivative. 2 times 1 2 minus 1 5 copy, then x wala naman kasi 1 times 5 is just negative 5, then x raised to 1 minus 1, then 0 x raised to 0 is 1. So yeah, then the derivative of 3 is just 0. So 2x minus 5 is the derivative. This is the derivative of this function. Okay, so it's just easy to understand if you know the rules of differentiation and finding the derivative. Also, additional information, if I think it's more complicated when you are finding the derivative of a function when the function is like this: x plus 16 times x plus 16, like that. So the product, you will use the product rule of the rules of differentiation and finding the derivative of this function. Also, this is for the quotient. For example, you are finding for the derivative of x squared plus 16 over x cubed. You will use this formula in finding the derivative of this function. But you can also use the formula, the long method, which is f prime x is equals to f of x plus h minus f of x over h. But masyadong mahaba kasi kaya mahirapan kayo. So just use this formula to find the derivative of a quotient. And this one, actually this is two formula. This is the rules, this is the shortcut in finding the derivative of exponential function. For example, you have 9x raised to x squared plus 3. You can use this formula to find the derivative of this function. And that's all for today's video. I hope you learned something, and I hope you could use it in future references. Thank you for listening.